Hi students, good morning to all. Today, say we read 10th chapter, straight lines. A distance of your point from your line. Take your book, page number 225. Page number 225. That is a perpendicular distance between point and line. Okay. Formula derivation. Distance between point from a line. And line or from a line. Okay, right. Let us consider a line L. Let us consider a line L is ax plus by plus c equal to 0. Ax plus by plus c equal to 0. Draw this line in xy plane. This is xy plane. This is ax plus by plus c. This line is L is ax plus by plus c equal to 0. That is L. This line name is L. Okay, right. Distance between this line to any one point. That is, any one point is, let us consider x1 comma y1. P of x1 comma y1. So distance between the point x1 comma y1 from the line ax plus by plus c equal to 0. Okay, right. This is a required formula. So this line is perpendicular. This line is perpendicular, drawn from P to this line. That is PM. That is PM. This point is called Q. This point is R. So connect these points R and P and Q. We have a triangle PQR. Triangle PQR. See this triangle, this diagram. PQR is a triangle. PM is perpendicular to the line ax plus by plus c equal to 0. So required formula is perpendicular distance between this point x1 comma y1 from the line ax plus by plus c equal to 0. Okay, right. This line is ax plus by plus c equal to 0. So this point Q is x intercept. This is distance OQ is a x intercept. Okay, x intercept. So y answer 0. Y answer 0. So any point on this x axis is y value is 0. So here y equal to 0. Then x is y equal to 0, which implies by is 0. So ax plus c equal to 0. Then x equal to minus a by c. Sorry, minus c by a. Minus c by a. X equal to plus y is value 0. So by is 0. So ax plus c equal to 0. Then x equal to minus c by a. This point is minus c by a comma 0. Okay, coordinate of Q. And coordinate of R is, this is y intercept. Y intercept, that means here x value is 0. Any point on this y axis, then x value is 0. So put x equal to 0. X equal to 0. And by plus c equal to 0. Then y is equal to minus c by b. Minus c by b. So the coordinate of the point R is 0. X value is 0. So y value is minus c divided by b. Minus c divided by b. So let us consider the point P is x1 comma y1. Point P is x1 comma y1. Right. First of all, find perpendicular distance between P to M. That is P to this line ax plus by plus c equal to 0. Here, see, PQR is a triangle. PQR is a triangle. PQR is a triangle. We know that the area of triangle the area of triangle, formula triangle PQR, triangle PQR is base into heights, base into height. Here base is QR, QR is base and height is PM. So the area of triangle PQR is 1 by 2 into base into height, base into height. So area is 1 by 2, base, here base is QR into and height is PM, height is PM. Okay, right. So required answer, the perpendicular distance from the line to point x1 comma y1, so PM. So PM is equal to, which implies PM is equal to 2 into area of triangle PQR, 2 into, here 1 by 2 multiple this area, so 2 into area of triangle PQR divided by distance between Q to R. So this is required answer, perpendicular distance between this point to this line. Okay, right. So first of all, find area of triangle PQR. Area of triangle PQR is we know that the formula passes this triangle 3 vertices PQR. Let us consider PQR are x1 y1, x2 y2 and x2 y3. This formula is 1 by 2 of modulus of x1 into y2 minus y1 plus x2 into y2 minus y3 minus y1 plus x3 into y1 minus y2. Already this formula studied in last 10th standard coordinate geometry. So 1 by 2 of x1 into y2 minus y3. Here x1, this is x1 y1, this is x2 y2, this is x3 y3. So x1 into y2 minus y3. y2 is 0 and y3 is minus c by b. So y2 is 0, right, x1 comma y1 p, and q is minus c by a comma 0. This is x2 y2 and r is 0 comma minus c by b. This is x3 y3. Okay, right. So x1 is also x1, y2 minus y3, y2 is 0 minus y3 value is minus c by b, so plus c divided by b plus x2 is, here x2 is minus c by a into y3 value is minus c divided by b minus y1 value is y1 plus x3 is 0 into anything 0. Okay, right. Remaining 1 by 2 of x1 into c by b, x1 c divided by b minus c by a into minus c by b minus y1. So minus c by a into minus c by b is equal to plus c squared by ab minus c by a into minus y1 is plus c by a y1. Okay, so this common term here, common term is c and c by ab. So take c by ab on both terms. So 1 by 2 into modulus of c by ab. Take modulus of c by ab on both terms. Remaining here x1 into c by b only. So c by ab take, so multiple a numerator. So ax1 plus c squared by ab. Take c by ab, remaining c only. And third one term c by a only, take c by ab. So multiple b and numerator. So by1 plus by1. Okay, right. So 1 by 2 of modulus of c divided by ab C divided by AB into modulus of AX1 plus BY1 plus C. AX1 plus BY1 plus C. This is area of triangle PQR. Okay, right. Next one, here 2 into area of PQR divided by QR. So find the distance between QR. Right. And another one information, Q is minus C by A comma 0 and R is 0 comma minus C by B. So distance between Q to R. Distance between Q to R. The formula is root of x2 minus x1 the whole square plus y2 minus y1 the whole square. Here Q and R. x2 minus x1 the whole square. So x2 minus x1, this is x2, this is x1. S0 minus C by A whole square is C square by A square. 0 minus of minus is plus. So plus C by A whole square is C square by A square plus y2 minus y1. Here y2 is minus C by B minus 0. Minus C by B the whole square is C square by B square. C square by B square. Right. Let us take C square divided by AB. A square B square on both term. So here C square A square only, so remaining B square. Multiple B square on numerator. Plus here C square by B square only, so here denominator A square B square, so multiple A square on numerator. So take C square by A square onto root. So C divided by AB into root of A square plus B square. This is QR. This one is QR. So required answer is PM. Required answer is PM. So substitute these values. Substitute these values. PM is equal to 2 into this value area of triangle PQR and QR. You substitute this equation number 1. 1 implies PM is equal to 2 into area of triangle PQR is 1 by 2 of C by AB into AX1 plus BY1 plus C. AX1 plus BY1 plus C. Here distance is positive, is also positive, so modulus. And divided by QR value is modulus of C by AB. Modulus of C by AB into modulus of root of A square plus B square. A square plus B square. So here C by AB cancel, 2 cancel. Remaining modulus of AX1 plus BY1 plus C divided by root of A square plus B square. So square root is also positive. So root of A square plus B square. So therefore the perpendicular distance between the point x1 comma y1 and the line ax plus by plus c equal 0 is modulus of ax1 plus by1 plus c divided by root of a square plus b square. Root of a square plus b square. Very important formula. Okay. Perpendicular distance between point x1 comma y1 from the line ax plus by plus c equal 0 is this formula. Okay. Right. Next, distance between two parallel lines. First one, distance between point and line. Perpendicular distance between point and line. Here distance between two parallel lines. Two parallel lines. Okay. Let us consider two parallel lines. First line is line equations. Let us consider the parallel lines are y equal to mx plus c1 and y equal to mx plus c2. This is equation number 1, first line. This is equation number 2. Here, say y equal to mx plus c1 and y equal to mx plus c2. Say slopes are equal. Why sir? So given two lines are parallel, you know that already studied for the exercise number 10.1, two lines are parallel, then the slopes are also equal. So these two lines are parallel, so slopes also equal. So first equation is y equal mx plus c1 and second equation is y equal to mx plus c2. Right. Draw lines in xy plane. This is xy plane. First line. This is y equal to mx plus c1. Line 1. And second one line is parallel to this line. So this is y equal to mx plus c2. This is second one line. This line is parallel to this line. Okay, so these two lines are parallel. So we have to find distance between these two lines. Distance between these two lines. This is x-intercept. Let's consider this point is A. Perpendicular distance. Draw a line perpendicular from a point A to this line y equal to mx plus c2. Y equal to mx plus c2. We have this distance D. Required distance is AM. That is called D. Okay, right. The coordinate point A is, here A is x-intercept in the first equation. So x-intercept means y is 0. So substitute this value y equal to 0, which implies from equation number 1 y equal to 0, mx plus c1 equal to 0, mx plus c1 equal to 0, then x is equal to minus c1 by m. X equal to minus c1 by m. So the coordinate point of A is minus c1 by m minus c1 by m comma 0. This is x coordinate. So minus c1 by m. Here x is left, A is left of x axis. So plus c1 by m or minus c1 by m. So minus c1 by m comma 0. Minus c1 by m comma 0. Okay, right. So distance between this point A minus c1 by m comma 0 from the line y equal to mx plus c2. So this line is perpendicular to this line AM is perpendicular to this line y equal to mx plus c2. Already first equation, distance between perpendicular distance between point and line formula. So perpendicular distance, you know that perpendicular distance between point and line, point x1 comma y1 and the line ax plus by plus c equal to 0 is d equal to modulus of ax1 plus by1 plus c divided by root of a square plus b square. Okay, previous formula. Right. Here required answer is AM. That is distance between two parallel lines. This AM is perpendicular to y equal to mx plus c2. So the point A is minus c1 by m comma 0. So D is equal to, here A is minus c1 by m comma 0. And this line is here, line is y equal to mx plus c2, that is mx minus y plus c2 equal to 0. Okay, right. So substitute this value. So this is x1 comma y1. The line equation is mx minus y plus c2 is equal to 0. So substitute these values in equation number 1. Okay, right. So D is equal to modulus of A is, here ax1 plus by1 plus c. ax1 plus by1 plus c is mx minus y plus c2 equal to 0. So x is replace x1. So m into minus c1 by m into minus x is replace x1 value. So minus c1 by m plus minus y value is 0 plus c2 divided by root of a square means coefficient of x1. So coefficient of x1 is here m. So m square squared plus, and coefficient of y is minus 1 the whole square, so which is m cancel and minus c1 plus c2, that is modulus of c2 minus c1 or c1 minus c2 divided by root of 1 plus m squared, 1 plus. So distance between the point A minus c1 by m comma 0 from the line y equal to mx plus c2 is, these two lines are parallel, so d equal to modulus of c2 minus c1 divided by root of 1 plus m squared. Okay, generally distance between two parallel lines formula is d is equal to modulus of, this is between two constants, so modulus of c2 minus c1 divided by root of x coefficient is a, so root of a square plus b square. This is distance between two parallel lines formula, general formula. Okay, so first one formula, perpendicular distance between point and line is d is equal to modulus of ax1 plus by1 plus c divided by root of a square plus b square. This is first one formula. Second one formula is distance between two parallel lines, is d equal to modulus of c2 minus c1 divided by root of a square plus b square. Okay, right. Exercise number 10.3, question number 4. Find the distance of the point minus 1 comma plus 1, points minus 1 comma plus 1 from the line (12 of x plus 6) is equal to 5 of y minus 2. Find distance between point and line. Okay, right. Point is x1 comma y1. Point x1 y1 is equal to, let x1 y1 is equal to minus 1 comma plus 1, and the line 12 of x plus 6 is equal to 5 of y minus 2. Simplify this. This line is already ax1 plus by plus c equal 0 form. So 12 of x plus 6 is 12x plus 12 into 6, 72 is equal to 5y minus 10. So 12x minus 5y plus 82 equal to 0. 72 minus 10 plus 100 plus 10, so 72 plus 10, 82. So 12x minus 5y plus 82 is equal to 0. Okay, right. So distance between the point minus 1 comma plus 1 and this line 12x minus 5y plus 82 equal 0. We know that the formula, distance between the point x1 y1 and the line ax plus by plus c equal to 0, and the distance is d is equal to modulus of ax1 plus by1 plus c divided by root of a square plus b square. Here x1 y1 is minus 1 comma plus 1, and a is 12 and b is minus 5, c is 82. Substitute this value, so d is equal to modulus of ax1 plus by1 plus c. A is 12 into, this is a, so a is equal to 12 and b is equal to minus 5 and c equal to 82, and x1 value is minus 1 plus b is minus 5 into y1 value is plus 1 plus c is 82, divided by root of a square plus b square. Here a square value is 12 square, 144 plus b square minus 5 the whole square is 25. So distance D is equal to, here minus 1 into 12 and minus 5 into 1, minus 12 minus 5 plus 82 modulus divided by root of 144 plus 25, 169. Okay, simplify this. Minus 12 minus 5 is minus 17. So minus 17 plus 82 divided by root of 169 is equal to, root of 169 is 13. Root of 169 is 13. Minus 17 plus 82 is 65. Modulus of 65 is also 65. So 65 divided by 13. 65 divided by 13 is equal to 5 times 5 13s are 65. So 5 units. So required distance is 5 units. 5 units. Therefore, the distance between the point minus 1 comma plus 1 from the line 12 of x plus 6 equal 5 of y minus 2 is 5 units. Okay, right. Next question number 5. Find the points on the x-axis whose distance from the line. Find points on the x-axis. So find on the x-axis whose distance from the line x by 3 plus y by 4 equal to 1 or 4 units. So given information distance d equal to 4 units and the line equation is intercept from x by 3 plus y by 4 equal to 1, and another information, a point on the x-axis, point is on the x-axis. So let us consider a point is on x-axis, so a comma 0. So x-axis y coordinate value is 0, so x coordinate is, let us consider a distance, so a comma 0. Let us consider the point a comma 0. So we have distance is 4, so also the given information distance is 4. We have the answer is a. Okay, right. A line is given, line equation is x by 3 plus y by 4 equal to 1. Simplify this. 4x plus 3y equal to 12. So 4x plus 3y minus 12 equal to 0. This is ax plus by plus c equal to 0 type. Okay, right. So we know that perpendicular distance between point and line formula is d is equal to modulus of ax1 plus by1 plus c divided by root of a square plus b square. Okay, right. Here x1 y1 is x1 comma y1 is equal to a comma 0 and caps a is equal to coefficient of x, that is 4, and caps b is equal to coefficient of y 3 and c is constant minus 12. Substitute this value is in given formula. So d is equal to modulus of ax1 plus by1 plus c. A is 4, 4 into x1 is a plus by1, b into y1 is 0 plus c value is minus 12 divided by root of a square plus b square. A square is 4 squared 16 plus b square is 3 squared 9. 3 squared 9. So simplify this value. Here another one given information, distance is 4 and distance is 4 unit. Okay, so 4 is equal to modulus of 4a minus 12. 4a minus 12 divided by root of 16 plus 9. 16 plus 9 is 25. So root 25 is equal to 5. Root 25 is equal to 5. So 4 into 5 is equal to 4a minus 12. Take 4 on both two terms. So 4 of modulus a minus 3. So 4 divided by 4 on both sides. So 5 is equal to modulus of a minus 3. Okay. So modulus means plus or minus value. So first case 1, let us consider 5 is equal to plus a minus 3. Then a is equal to 5 plus 3, 8. And second one, 5 is equal to minus of a minus 3. So here modulus value, so plus value take and minus value. So phi equal minus of a minus 3, phi is equal to, so a minus 3 is equal to, a minus 3 equal to minus 5. So a is equal minus 5 plus 3, that is minus 2. Minus 5 plus 3 equal minus 2. So the value a equal to 8 or a equal to minus 2. So the required point is 8 comma 0 or minus 2 comma 0 or minus 2 comma 0. This is the required answer. Okay, right. Okay, next question number 6. Find the distance between the parallel lines. Use the second one formula. So first one, 15x plus 8y minus 34 equal 0 and 15x plus 8y plus 31 equal to 0. This is a very simple question. So first one question homework and second one question. Sixth one, second one. L of x plus y. L of x plus y plus p equal to 0 and another one line is L of x plus y minus r equal to 0. Minus r equal to 0. Find the distance between parallel lines. Okay. These two lines are parallel. See here, L of x plus y, that is Lx plus Ly plus p is equal to 0 and Lx plus Ly minus r equal to 0. Here x coefficient is same and y coefficient is also same. So only constant, only different. So you know that two lines are parallel, then the coefficient of x and y are same and differ only constant. Okay. So we know that distance between the two parallel lines, distance between the two parallel lines formula is c1 minus c2 or c2 minus c1 divided by modulus of c1 minus c2 divided by root of a square plus b square. Okay, right. Here c1 is p. Here c1 is equal to p and c2 is equal to minus r. c2 equal to minus r. A equal to L and also b is equal to L. A and b is also same. So substitute this value, d is equal to modulus of c1. c1 is p minus r, so plus r divided by root of a squared is L squared plus b squared is also same L squared. So simplify this value. So d is equal to modulus of p plus r, modulus of p plus r divided by root of L squared plus L squared is 2L squared. 2L square. So the d is equal to 1 by root 2 into modulus of p plus r divided by root of L square. Root of L square is L. Root of L square is L units. This is required distance between these two parallel lines. Okay, right. Next question number 15. Listen, the perpendicular from the origin to the line y equal mx plus c. The perpendicular from the origin to the line y equal mx plus c meets it at the point minus 1 comma 2. Find the values of m and c. Find the value of m and c. So perpendicular distance, let xy plane. Perpendicular distance from the origin, this is y equal to mx plus c, y equal to mx plus c. So this line is perpendicular to y equal to mx plus c from the origin 0 comma 0 meet at minus 1 comma 2, minus 1 comma 2. So this point is minus 1 comma 2. Okay, find the value of m and c. Right, listen. This line is perpendicular to y equal to mx plus c. So given line is y equal to mx plus c. This y equal to mx plus c is y equal to mx plus c is perpendicular to the line 0 comma line passes through zero comma 0 and minus 1 comma 2. These two lines meet at the point minus 1 comma 2. First of all, find the slope of the line, perpendicular line. So slope of the line passes through 0 comma 0. This is origin, and minus 1 comma 2 is slope is equal to y2 minus y1 formula. Here y2 is 2 minus 0 divided by y1 is 0 divided by x2 minus x1, x2 is minus 1 minus 0 is equal to minus 2. So slope of this line, a perpendicular line from the origin, is minus 2. Our required answer is slope of this line y equal to mx plus c. That is m answer. So we know that two lines are perpendicular. Two lines are perpendicular to each other. Then the slope m1 into m2 is equal to minus 1. m1 into m2 is equal to minus 1. Here m1 is minus 2, slope of this perpendicular line. So minus 2 into m2 is, this is slope of this line y equal mx plus c. Here m2 is m2 is called m, is equal to minus 1. So minus 2m is equal to minus 1, and m is equal to plus 1 by 2. m equal to plus 1 by 2. So I substitute this value in equation number 1, y equal to mx plus c, y equal to mx plus c, and also y equal to mx plus c is passes through minus 1 comma 2. So x is minus 1 and y is 2. So substitute this value, y is equal to 2 and m is 1 by 2, x is minus 1 plus c. So 2 is equal to minus 1 by 2 plus c, then c is equal to 2 plus 1 by 2. So c value is 4 plus 1, 5 by 2. So therefore the required answer m is 1 by 2 and c is equal to 5 by 2. Okay, very simple question, right? Next question number 16. If P and Q are the length of the perpendiculars from the origin to the lines, P and Q be the length of the perpendicular, distance between origin to the lines. First line x cos theta minus y sin theta is equal to k cos 2 theta. K cos 2 theta. This is equation number 1. And second one, Q is the length of the perpendicular from the origin to the second line, x secant theta minus plus y cosecant theta equal to k. This is equation number 2. Then prove that p square plus 4q square equal to k square. So we have to prove p square plus 4q square equal to k square. We need to prove p square plus 4q square is equal to k square. Here p is perpendicular distance between the first line and q is perpendicular distance between the second line from the origin. Okay, right. First of all, we know that perpendicular distance between a point x1 comma y1 and the line ax plus by plus c equal to 0 is d equal to modulus of ax1 plus by1 plus c divided by root of a square plus b square. Okay, right. First one, find a perpendicular distance between the origin to the line x cos theta minus y sin theta equal to k cos theta. That is minus k cos 2 theta. Okay, perpendicular distance between origin 0 comma 0 and the line x cos theta minus y sin theta and cos k cos 2 theta is minus k cos 2 theta equal to 0. So P is a perpendicular distance. P is a perpendicular distance between this line from origin. So P is equal to modulus of ax1 plus by1 plus c. Here a is coefficient of x cos theta. A is cos theta. x1 is 0 plus by1. Here b is minus sin theta and y1 is 0 plus c. Constant is minus k cos 2 theta divided by root of a square plus b square. A square is cos square theta plus b square is minus sin theta, the whole square is sin square theta. Here a is capital A is cos theta, b is minus sin theta and c is minus k cos 2 theta. x1 y1 is 0, 0. Substitute this formula. We have P is equal to modulus of minus k cos 2 theta. Cos theta and 0 is 0, minus sin theta is 0 is 0. Remaining minus cos 2 theta. So modulus of minus cos 2 theta is modulus of plus cos 2 theta divided by root of cos square theta plus sin square theta is 1. So root of 1 is equal to, so P value is k cos 2 theta. P value is k cos 2 theta. Right. Next, find the value of Q. Q is a perpendicular distance between the line x secant theta plus y cosecant theta equal k from the origin. So second one, perpendicular distance between 0, 0 from the origin, that is 0, 0 and the line x secant theta plus y cosecant theta minus k equal to 0. Minus k equal to 0 is Q. Here perpendicular distance between x cos theta 0, 0 and this line is P. Right. Find the value of Q. So Q is equal to modulus of ax1 plus by1 plus c. Here a is secant theta. Here a is cos theta minus sin theta, and also here a is secant theta and b is cosecant theta and c is minus k. And x1 y1 is 0, 0. So x1 y1 is 0, 0. So ax1 0 into any1 0 and by1 is also 0 and constant c is minus k. Okay, x1 y1 value is 0. So ax1 plus by1 term is also 0. Constant term minus k divided by root of a square plus b square. A is secant theta, so secant square theta plus b square is cosecant square theta. Okay, right. Modulus of minus k. So modulus of minus k is plus k. So k divided by root of secant square theta plus cosecant square theta. This is k value. So we need to prove p square plus 4q square equal to k square. So first one, p squared plus LHS. P squared plus 4q squared is equal to k squared. So p squared plus 4q squared. So P answer is k cos 2 theta. So k cos 2 theta whole square is k squared cos squared 2 theta plus 4q squared. Q squared value is k by root of secant square theta plus cosecant theta. So q squared. So 4 into k squared divided by root and square is cancelled, remaining secant square theta plus cosecant square theta. Okay. So k squared into cos 2 theta square 2 theta plus 4 into k square divided by secant square. You know secant square theta is 1 by cos square theta plus cosecant square theta is 1 by sin square theta. theta. So simplify this value, k squared cos squared 2 theta plus 4 into k squared divided by cross multiplication sin square theta plus cos square theta, sin square theta plus cos square theta whole divided by cos square theta into sin square, that is k square into cos square theta into sin square theta. You know that sin square theta plus cos square theta value is 1, so remaining k squared cos squared 2 theta plus 4 into k squared into cos square theta into sin square theta, sin square theta. So simplify this value and p squared plus 4q squared is equal to both term k squared is common, two terms here k squared and also same k squared. So k squared is common, k squared of cos squared 2 theta, cos squared 2 theta plus 4 cos square theta into sin square theta is written as 2 sin theta cos theta the whole square. So 2 square is 4 and sin theta whole square is sin square theta, cos theta whole square is cos square theta. So 4 into cos square theta into sin square theta is written as 2 sin theta cos theta the whole square. You know that sin 2 theta formula, sin 2 theta is 2 sin theta cos theta. So cos squared 2 theta plus 2 sin theta cos theta is sin 2 theta. The whole square is sin squared 2 theta. Whole square is sin squared 2 theta. See, cos squared 2 theta plus sin squared theta, identity value. Sin squared theta plus cos squared theta is 1. So 1 is equal to k square. K square is RHS. So we need to prove p square plus 4q square is equal to k square. So let us consider LHS is p square plus 4q square. The answer, final answer is k square. So k square is also RHS. Hence proved. Okay. Right. Next question number 17. The triangle ABC. The triangle ABC. The vertices A is 2, 3. Triangle ABC. Vertices is A is 2, 3. 2, 3 and B is 4, minus 1 and C is 1, 2. 1, 2. Find the equation and the length of altitude from the vertex A. That is this line. So D. Okay. Right. Given information, ABC be a triangle and then so vertices A is 2, 3 and B is 4, minus 1 and C is 1, 2. Find the equation from the vertex A. Find the altitude. Equation of the altitude from the vertex A. This is vertex A. So the altitude AD is perpendicular to BC. So required answer is the equation of line AD and the length of this line. Okay. Right. First of all, ABC be a triangle. Triangle and AD is perpendicular to BC. AD, this line AD is perpendicular to BC. Required answer is the equation of AD and distance between, perpendicular distance between A and this line BC. First of all, find slope of the line BC. Slope of the line BC. It is slope of the line passes through minus 4, minus 1 and 1, 2 is y2 minus y1 is x1 y1 and x2 y2. y2 is 2 minus y1 is minus 1 minus of minus 1 plus 1 divided by x2 minus x1 1 minus 4 1 minus 4 is equal to minus, so 3 divided by minus 3. 3 divided by minus 3 is equal to minus 1. So slope of the line BC is Slope of the line BC is minus 1. Okay. So required answer equation of this line. So first of the slope of this line AD. The slope of this line AD is the line altitude AD is equal to minus 1 divided by slope of the line AB. You know that this line AD is perpendicular to BC. So these two lines AD and BC are perpendicular to each other. So the slope of this line altitude AD is equal to minus 1 by slope of the line AB. Minus 1 by slope of the line AB. So is equal to minus 1 by slope of the line AB is minus 1. So minus 1 by minus 1 is equal to plus 1. So slope of the line altitude AD is equal to plus 1. Okay. Right. So M is equal slope is 1. First of all, find the line equation. The equation of line passes through vertices 2, 3 and slope is 1. Slope 1 is a formula. You know that formula y2 minus y1 is equal to m into x2 minus x1. M into x2 minus x1. Here 2, 3 is x1 y1 and slope is this is m. This is m. So substitute this value y2 minus y1 is equal to m into x minus x1. So y1 value is 3 is equal to m value is 1 into x minus x1 value is 2. So simplify this, x minus 2 equal to y minus 3. So x minus y plus y is converted in minus y. So x minus y, already minus 2, here minus 3 is converted plus 3. So minus 2 plus 3 is plus 1 equal to 0. So x minus y plus 1 equal to 0. X minus y plus 1 equal to 0. Therefore, the equation of altitude is altitude AD is x minus y plus 1 equal to 0. And also find the length of this line AD. So length of this line is perpendicular to BC. So distance between perpendicular distance between point and line. Perpendicular distance between point and line. So this line equation is x minus y plus 1 equal to 0. This line equation is x minus y plus 1 equal to 0. Okay, right. So we need the length of perpendicular distance between vertex 2, 3 and this line BC. So first of all, find the equation of line BC. The equation of line BC is same formula y minus y1 equal to m into x minus x1. Here B is minus 4 minus 1 and C is 1 2. You know that the formula is y2 minus y1 y minus y1 is equal to y2 minus y1 by x2 minus x1 into x minus x1. Okay, right. Already slope of the line BC is minus 1. So substitute this value. This is minus 1. This is minus 1. And y minus y1 is 4. y1 is minus 1. Minus 1 is minus of minus 1 plus 1 is equal to y2 minus y1 by x2 minus x1 is also find minus 1 value. So into x minus x1 is 4. X minus x1 is 4. So y plus 1 is equal to minus 1 into x minus 4. Minus 1 into x minus 4. So y plus 1 equal to minus x plus 4. So x plus y minus 3 equal to 0. This is equation of line BC. So required distance is from the point 2 comma 3 to this line. So perpendicular distance between a point A is 2 comma 3 to the line BC, that is BC is x plus y minus 3 equal to 0 is d equal to modulus of x1, modulus of a is 1, x1 is 2, so 1 into 2 plus by1 plus b is 1 and y1 is 3 plus c is minus 3 divided by root of a squared is 1 squared plus b squared is 1 squared 1 is equal to 2 plus 3 minus 3 plus 3 minus 3 cancel, plus 3 minus 3 cancel, remaining 2 divided by root 2 is equal to root 2. 2 by root 2 is root 2. Therefore, the required distance is root 2 units. Okay. Listen. Given information, triangle ABC and vertices 2 comma 3 and 4 comma minus 1 and 1 comma 2. Find the equation of the line, that is altitude from the vertex 2 comma 3, that is AD. So first of all, find the equation of altitude AD. Okay. So its altitude AD is perpendicular to BC. So find slope of BC and also find slope of AD. Okay. Substitute this value. So the equation of altitude AD is x minus y plus 1 equal to 0. And second one, and also find this length. This line is perpendicular to BC. So perpendicular distance between 2 comma 3 and this line BC. So find BC, equation of BC. So equation of BC is x plus y minus 3 equal to 0. So substitute this. A formula is d equal modulus of ax1 plus by1 plus c divided by root of a square plus b square. So a is 1 and b is 1 and c is minus 3 and x1 y1 is 2 comma 3. Substitute this. We have that length of the altitude AD is root 2 units. Very simple question. Okay. Right. So last question number 18. If P is a length of perpendicular from the origin to the line, P is a length of perpendicular from the origin to the line whose intercept on the axis A and B. So given x intercept is A and y intercept is B. Then the equation of line is x by A plus y by B equal to 1. This is intercept form. Okay. Right. And P is the length of the perpendicular from the origin to this line. P is length of the perpendicular distance from origin 0 comma 0 and this line x by A plus y by B equal to 1. Then show that we need to show that 1 by p square equal to 1 by a square plus 1 by b square. 1 by a square plus 1 by b square. Right. Listen. The equation of line is x by a plus y by b equal to 1. So the intercept axis A and B. So x by a plus y by b plus a equal to 1. Simplify this, bx plus ay. So cross multiplication. Bx plus ay is equal to ab. So bx plus ay minus ab equal to 0. So given information P is perpendicular distance between origin and 0 comma 0 and this line, and bx plus ay minus ab equal to 0. So you know that the perpendicular distance between point and line form is d is equal to a modulus of ax1 plus by1 plus c divided by root of a square plus b square. Here x1 y1 is 0 comma 0. This is x1 y1 is 0 comma 0 and a is b, caps a is b and caps b is a and caps a is minus ab. So perpendicular distance between 0 comma 0 and this line is p is equal to modulus of a x1. Here a is b, so b of 0 plus a of 0 plus constant is minus ab, so minus ab divided by root of b square plus a square, that is a square plus b square. So simplify this. Modulus of minus ab is plus ab divided by root of a square plus b square. So p is equal to ab by root of a square plus b square. So we need to show 1 by p square equal 1 by a square plus 1 by b square. So square on both sides. So p square is a square b square by a square plus b square. So reciprocal of both sides, take reciprocal on both sides. So 1 by p square is equal to a square plus b square divided by a square b square divided by a square b square. Simplify this. 1 by p square is equal to a square by a square divided by a square b square plus b square divided by a square b square. B square cancel, a square cancel. Remaining 1 by p square is equal to 1 by b square plus 1 by a square. Therefore 1 by p square is equal to 1 by a square plus 1 by b square, hence shown. Okay, very simple question. And remaining, so this exercise is completed. 10.1, 10.2 and 10.3 are completed. Examples are homework. Next, miscellaneous example and exercise is in next class. Okay, bye.